habitable environments.
The next item to be added to the menu? Yellow stars. We're looking for something around 5 billion years old, an average size. Wait a second, don't we have one right here? So why not use the sun?
We've thought that our sun is the prototype for kind of 5 billion year old average yellow stars. What we've learned recently is that our sun is actually quite inactive for a 5 billion year old yellow star.
Typical Earthling behavior, really, thinking we're the example for the entire universe. But it turns out, yellow stars are found throughout our galaxy, and they tend to erupt with life-altering activity more often than our sun does. So, if we want to understand if they can still support life, we'll need more data than our sun can give us. That's why 2 rocket teams are looking to Alpha Centauri A and B.
The reason why we're targeting Alpha Centauri is that it's our nearest solar twin. So in many, many ways, it's just like the sun. It has almost the same mass, it's a very similar age, and it's nearby, which is always great.
And with the help of NASA sounding rockets, they'll capture light from those stars that doesn't make it to the ground. This range of highly energetic ultraviolet light has never been measured before for these stars. Even small differences in this UV light from a star can determine whether a nearby planet can support life or not. But the Alpha Centauri system isn't visible from most places in the US. It's best studied from the southern hemisphere. That's why we're here in northern Australia, in the traditional homelands of the Yolngu people. They've been observing the stars here for tens of thousands of years. I'm here with 2 rocket science teams, Sistine and Deuce, and a crew of about 50 NASA engineers, rocket specialists, and support staff. In partnership with Equatorial Launch Australia and the Gumatch Corporation, they've created an entire rocket range from scratch to help the scientists achieve their goals. In this series, you're going to meet these teams and follow their quest high above the Australian outback to see what it takes to make these first ever measurements from our closest stellar neighbors. We're going behind the scenes to learn more about the science of habitability and what goes into launching a rocket, dodging venomous snakes and crocodiles along the way. But first, we'll take a look at how this